Students, I am going to give you a few basics of transportation problem, as you have already seen in the video I have sent to you. In the transportation problem, the main components are, first of all, the components are, if you see, it's the origin or source. What is meant by origin and source? It is for example, the manufacturing unit or production unit, wholesale market or wholesale stores, and suppose milk production farm or any production farms. These are the examples of a origin or source. Then some destinations. There will be some destinations. What is these destinations? Destinations are distributors. Production unit is producing something, and that has to be distributed to the distributors. So this is called one destination. Similarly, retail shops will be getting the things from wholesale shops. Then you can say wholesale or retail shops, because wholesale can get the goods from the godowns, and also these are all can be taken as destinations. Now, apart from these two, is important thing is the availability of the origin. How much quantity is available in those origins or total products, like a manufacturer. So, for example, if a car manufacturing units are producing 100 cars a day or 50 cars a day. So, this is available to distribute only 50 cars. So, that is called availability at the origin. And distributors are those, suppose car distributors, they want they can sell 5 cars a day or something like that, or 10 cars a day or 100 cars a day. Those are requirement, because they will require 100 cars or 10 cars or 20 cars from the manufacturing unit. So, distributors requirement is at the destinations, or so this is also known as the demand. What is the demand of this destination point? Okay. So, these four are very, very important thing. So, what is the problem of transportation problem? It deals with an important thing, that the problem has to deal with the same product. So, the problem, if it is a problem of manufacturing, product manufacturing, car manufacturing, milk distribution of milk product. So, it has to be the same product has to be given. We cannot have a transportation problem by the one source sending cars, another source sending some other thing. So, that is not the thing. Only the same product has to be formulated, okay, in this transportation problem. Similarly, each origin or sources are expected to supply to the number of destination. The destinations are expected to order to all the sources. They have to order the things from all the sources. So, all the sources has to be involved, and all the sources has to supply to all the destinations, okay. Now, transportation problem it can be also said as a special kind of linear programming problem. In this problem, the objective function is to minimize the total transportation cost, because why? If you have a source and if you have a destination, you have to send your product to the destination by transportation. So, transportation cost may be very huge, and this transportation cost may be the cost of fuel, cost of employing manpower, or any other cost, whatever cost incurred in transporting one goods from one place to another is called as total transportation cost, while transporting goods from sources to destination. I am giving you an example. Suppose we have 3 farms, S1, S2, S3, and these are known as the sources or origin, and they are producing milk, and the daily production of these 3 farms are, suppose S1 produces 6 million liters of milk, S2 produces 1 million liters of milk, and S3 10 million liters of milk, and that means the availability or supply position of these sources, S1, S2 and S3, and this 6 million liter, 1 million liter and 10 million liters. Okay. Now, suppose each day milk produced in these farms are transported to distribution centers, and suppose there are 4 distribution centers. I am just naming them as D1, D2, D3 and D4, and daily requirement of this, and this is also known as demand. What is the demand in those distribution centers? Of the distribution centers are, suppose D1 needs 7 million liters, D2 needs 5 million liters to be distributed. Similarly, D3 3 million liters and D4 2 million liters. Okay. Now, the thing is, now again the cost of transportation of 1 million liter from each sources to its destinations are described it. I am giving you one graph like this. These three are, this S1, S2, S3 are my sources, D1, D2, D3, D4 are my destination or these distribution centers. From S1 to D1 it takes 200 rupees, in 100 rupees, that means 200 rupees. This is what I am writing. S1 to D1 rupees 200 rupees, S1 to D2 300 rupees, S1 to D3 again 1100 rupees, this is 1100 rupees, S1 to D4 600 rupees. So, I can put in 100 rupees, I can put 2, 1, 2, 3, 11 and 7. Similarly, S2 to D1, S2 to D2, S2 to D3 and S2 to D4 are given as like this. S2 to D1 is 100 rupees, so I will putting 1. S2 to D2 there is no cost incurred. So, I was just putting 0 cost. So, there is no transportation cost for traveling, sending the product from S2 to D2 is 0. S2 to D3 is 600, so I am putting a 6 here, and then S2 to D4 is 100, so I am putting 1. Okay. Similarly, S2 to S3 to D1, S3 to D2, S3 to D3 and S4 for D4 are given like this. 5, say 5, first one is 5, S3 to D1, 5, then 8, then 15 and then 900. So, this is the cost of the transportation. Now if I see that, so okay, our aim is to find out how much will this be. For example, if S1, if D1 needs 7 million liters, it cannot be only getting from getting from the source 1 because it has only produced 6 million liters, S2 1, but S3 10 million liters producing. So, there has to be distributed, there has to be the D1 has to get from all the sources, maybe 6 liters from here, 1 liter from here, so 7 liters is met, or it can have only from S3 as 7 liters, so that it can have 10 liters, 10 million liters are already capacity is there. So, you do not know how much liters will be distributed from which sources. Okay. So, these are your unknown thing. So, let X, I, Z are the quantity of milk transported from ith resources to zth destination. In this case, I equal to 1 to 3 because you have 3 sources, and Z the destinations are 4 destinations. Now, source S1 to D1, what will be your what will be the amount? X11. I am defining as this variable X. So, X11 amount will be amount is sent from S1 to D1. Similarly, X12 amount is sent from S2 to D2 and so on. So, here you see this 1 and here 1 and this 1 represent 1 here. So, the suffix represent 1 to 2 means S1 to SD2, 1 3 means S1 to D3 and so on. And similarly, I can give. So, how many variables are, if you can say 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10, 11, 12. So, you have 12 variables are involved in this problem. So, you need to find out all these 12 variables, and the cost of transportation is given as I have said total cost. S1 to D1 it is said, S1 to D1 it takes rupees is 200 rupees. So, I am putting as 2 because I am just making it simplified 200 for 200 for 2, 100 for 1 and so such like that. So, 2 means S1 to D1, 1 unit 1 million liter to send from S1 to D1 is 2. So, X1 1 million liters, X1 1 million liters will take 2 X11. Similarly, 3 X13 depending upon the cost of transportation from S1 to D2 and all these things that can be written, these are total cost. So, what is total cost? And so on. This is from only S1 to D1, then S2 to D1, D2, D3, D4, then S3 to D1, D2, D3, D4, all that can be calculated as this one. So, what will be total cost of transportation from all sources to all destinations will be like 2x11, 3x1. This is from S1 to all four sources, four destinations. First source to all 4 destinations, and similarly second source to all second destination. And so, total you see the amount, the objective function z, this total cost is like you can get it like this. So, how many is, so our aim is to minimize Z. The number of variables are 12, as I have said, 3 sources and 4 destinations. Okay. So, what are the, now this is your cost function, this is your objective function or cost function. Now, what are the constants? Because every LPP has to have some cost function. So, total amount distributed for each sources must be equal to the availability of the sources. For example, S1 availability is 6 million liters, as I have said. It can only supply 6 million liters to all the destinations. And what are the destinations? What are the total amounts sent from S1 to all the sources? You see, S1 to D1 is X11, S1 to D2 is X12, S1 to D3 is X13, S1 to D4 is X14. So, if I add all these things, that has to be the total supply position of S, and what is our supply position of S is 6 million. So, X11 plus X12 plus X13 plus X14 has to be equal to 6. Okay. So, you have got something like this. So, similarly, from the source to S2 to all the destinations, total available supply is equal to 1 million liters. So, this will be equal to 1, and then similarly for the third sources to all 4 destinations are like this.